Welcome to a brief introductory to MATLAB fundamentals. This video will be using slides that are posted on the Learn at UW site under the content section labeled week 3. Okay, so to begin, opening MATLAB. MATLAB is under Core Software in the Start menu. MATLAB 2010A is what we're going to be using in this class. And then just as a quick side note, CAE allows you to tether MATLAB to your home computer as long as you renew your license every 12 hours or so. But you can search for tethered software on CAE and install MATLAB on your home computer so you can do some work from home. So when MATLAB pops up, this is the main MATLAB interface window. It has a bunch of components. The first we'll talk about is the workspace. These are the variables and data that are available for MATLAB to do work on. In this example, there's a variable called board and a variable called mymat. To the left, if you double click on board, an array editor will open up, which is just like a Excel spreadsheet view of the contents of the variable. You can see the contents of board here. On the bottom right is command history. These are previous commands that you have typed into the command window and are nice for you to go back if you forget what command you exactly typed in. So in the command window is where you can enter different commands, create variables, and do work. But to begin with, we'll talk about this current directory. So at the top, you can see the current directory is C users A Joshua documents MATLAB. Okay, when you open MATLAB, it'll default to some MATLAB folder. To the left, you can see the contents in this current directory. So the first thing you're going to want to do is set your current directory, and you have to do this each time you enter MATLAB. So we can see my current directory is A Joshua Desktop CE291 MATLAB. And to change this current directory, you can click on this Browse Folder button. And if we click, we can go to Desktop, and we can make a new folder, and I'll call this CE291. Okay? We recommend you make a folder to do all your MATLAB work for CE291. So I'll make this new folder. You can see that my current directory changes to the folder I just created, and the files in this directory are 0 because we haven't made any yet, but that will change. So you need to do this each time you open MATLAB. You need to change your directory to where your files are. So before we start talking about the commands you can type into MATLAB, I want to talk about some of the common data types that MATLAB uses. And this is a review slide from Excel, but the data types are still the same. So in MATLAB, a scalar value is just one single value, maybe a constant. Secondly, a vector, and maybe the most important data type for today's lecture is a list of values, or also known as a 1D array, and the dimensions are commonly n by 1. And in this example, there's 10. The dimensions are 10 by 1, 10 rows in one column. And lastly, there's a matrix, also known as a rectangular array or a 2D array. This has 2 dimensions, n by m, and in this example, this matrix is 10 by 3. So 10 rows and 3 columns. It's important to note that in MATLAB, the first identifier is the number of rows, and the second one is the columns. So MATLAB uses all these data types quite frequently in the program. So to begin, we want to do some interactive computation in the command window. I invite you to try some of these examples as well. So for example, in the command window, we can do some simple math. 4 squared is 16. 4 plus 6 times 2 divided by 3 plus 10. Okay, so you can do some quick computations in the MATLAB command window. And then, probably more importantly though, you want to store these results in a variable name so you can use them later. So some examples are, you type the name of the variable that you want, for instance a equals 3 plus 5. Okay, and now a is equal to 8, and you can see up in your workspace a variable gets created with the name a, and you can see the value is 8. So if we double click on this, the array editor should open up eventually. So the array editor, or variable editor, it says here, opens up, and it should give us a spreadsheet preview of the value of a. And there it finally is, and you can see that its contents are 8. So try and do a couple of these examples and get familiar with the names, naming variables. Some things to note are variable names must start with a letter, and they are case sensitive. So if you have a capital A in this previous example, on the command window, if I say a, which is 8, plus 1, the result should be 9. If I do capital A plus 1, MATLAB is going to give me an error, undefined function or variable a, because it's case sensitive. Okay, and then some other important instructions from this command window are clear, which deletes all the variables created in the workspace, and CLC, which clears the space. So we can see, maybe I'll make a couple more variables, b equals 10, c equals 15. We can see they're created in the workspace. If we want to delete everything and start fresh, we type in clear, and notice everything gets cleared. And then CLC will clear this command window history so you can start fresh. The next example we want to go over is how to create vectors in MATLAB. As seen here, the vector A can be declared using the curly brackets inside the curly brackets. And let's try this in MATLAB. So make sure you clear your workspace. So I'll declare vector A equals 1, 2, 3, 4, 5, 6, 7. End it with a curly bracket. Hit enter. And we can see immediately that in the workspace a vector A has been declared, and if we double click it and look in the variable editor, we can see the contents of this vector A. It has values 1 through 7. So now we can also access values in this vector with parentheses after the name. So A parenthesis 1 means the first value in vector A, which should be, if we look at the variable editor, 1. So we hit enter, and it returns the value 1. Similarly, if we want to access the last value, A7, it should be 7. Okay? So we can also use these values inside the vector to do operations. For instance, we can say B equals A1 plus A2. So if we look at this, we should expect to add 1 and 2, and the result should be 3. So B equals 3. This is a very important skill to have in MATLAB, to know how to use and reference values inside vectors. So if we look on the right here, this is kind of the representation of a vector, and we see the index values. In MATLAB, the index value starts from 1. So if we say A1, it should be the first value. Another thing to note is the special colon operator. The colon inside of parentheses of a vector means all. So if we go back to MATLAB and we do A colon, we should expect MATLAB to print out all the contents of A. And it does. 1, 2, 3, 4, 5, 6, 7. So here are a bunch of various commands to create vectors. I recommend you try all these and become familiar with them. The first one is especially important. When we want to create an evenly spaced vector, we can use these colons to mean create a vector. So this line is read as create variable b, which is a vector 0 by spacing 1 to 7. So if we try this in the command window in MATLAB, b equals 0 by 1 to 7, we should get a vector that's 0 to 7 spaced by 1. Okay? And we do, and we can click on B to view it in the variable editor, and we see it has values 0 to 7. We can also access variables from the vector again. You can do uneven or space vectors by more than one. You can, in this example, a space by 2. And then another command to create a vector is linspace. It's a function. So linspace, and then you enclose its input parameters into parentheses. So this line is read as d equals some function linspace from 0 to 10 with 6 values. So let's try this in the command window. D equals linspace 0 to 10 with 6 values. And we can see the results. There's 1, 2, 3, 4, 5, 6 values in this vector D from 0 to 10. So hopefully you can play with this and understand how linspace works. But there's many ways to create a vector. None of them are better than the others. However, when you start creating large vectors, it is easier to use this shorthand notation and let MATLAB do the work for you. So after vectors are matrices, and we can see how we declare matrices in MATLAB. It's similar to a vector that you enclose it in brackets, but you separate each row by a semicolon rather than a comma. So this is read, the first row, column 1 is 0, column 2 is 0, column 3 is 0, and then the semicolon means go to the second row. So in the second row, column 1 is 0, column 2 is 0, column 3 is 0, and then another row. So what this does is it creates a 3 by 3 matrix, which is indicated in this graphic over here. So let's try and create this in the MATLAB command window. Mat equals 0, comma 0, comma 0, and then semicolon to mean we're going to another row, and then so forth. Close the bracket and print it. And you can see that the matrix mat is made, and it's a 3 by 3 matrix full of zeros. These commands are functions that also create matrices. This mat2 will be the same exact matrix as mat1. It uses a zeros function, which creates zeros matrix. You specify the number of rows and the number of columns. And this is, and ones is similar to zeros. It'll create a 3 by 3 matrix of ones. Very similar to accessing values inside of a vector, you can access individual values inside of a matrix. And the way you do this is shown here. mat3, comma 2 accesses row 3, column 2. So it would access this value in this vector. So let's try to set the value in our matrix equal to 3 at row 3, column 2. So mat row 3, column 2 equals 3. And we can see that mat used to be all zeros. With this command, we said row 3, column 2 is now equal to 3. So mat's values have changed. Other commands that are very useful in matrices is this colon. So when you use a colon in this context, you say mat all rows, column 1 is now equal to 1. And similarly, you can say mat all rows, all columns equal to. So let's try this. Mat all rows with a colon, comma 1, column 1 equals 1. Let's see what happens. So we can see the result. All these rows in column 1 have been changed to the value 1. We can also use the colon for the column. You can say mat row 2 all columns equals 5. So we can see in row 2 and all the columns with the column, we change the value to 5. So learning how to use indices to reference values stored inside a vector and a matrix is critically important in MATLAB. I recommend you spend at least 5 minutes playing with accessing values inside of vectors and matrices.